Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super. Today's incident, we're going to focus on a power issue that disrupted one portion of one zone in the East-West region. The portion was AZ01, and it was part of that. It occurred on the 14th. It spread over to the 15th of August. It brought down infrastructure, and this infrastructure not only impacted virtual machines and virtual machine scale sets, but there are also some PaaS services that were impacted, such as Azure Backup, Microsoft Sentinel, API Management, Azure Database for PostgreSQL Flexible Servers, Azure SQL Database, Azure SQL Managed Instance, Azure Cache for Redis, and Azure Data Explorer. The interesting thing about these is that any customer who had these PaaS services configured zonally was unaffected, and any customer who didn't have them may have seen impact.
Yeah, that's right. It's really important that we focus on that availability zone scope of this incident here. To talk us through the incident and what happened and what we're learning from it, I'd like to introduce the engineering leaders who are joining us on our panel today. First up, we have Dana Nelson. Dana is our General Manager of Datacenter Operations in the Americas East region that oversees the region where this happened. We've also got Francis David. Francis is joining us. He's our Partner Engineering Manager from the Azure Compute side, and he's going to talk a little bit about our long-tail recovery for a small subset of virtual machines that didn't come back online in an automated way once power was restored.
Super. Dana, if I can start with you, in my mind, I mean, we run hundreds of data centers around the world, and similar to like fiber cuts on a network, I'm sure power issues are a dime a dozen. And surely our data center, our operations, everything should be resilient to these kind of things. What usually happens in a power issue, and how does the data center's resiliency usually kick in?
Yeah, Sammy, thanks. That's a great question. Consistent with our overall data center design approach and philosophy, the specific data center that was affected during this event has multiple utility feeds with backup diesel generators ready to pick up load seamlessly in the event of a utility outage or disturbance. As we talk about how things normally happen or should happen, I think there are two other components that I'd like to mention and make sure we're all aware of. The first would be the uninterruptible power supply. These power supplies in each of our data centers provide battery backup to carry critical loads during that transition period where the utility might experience an anomaly or an outage, and our emergency diesel generators are spinning up and preparing themselves to take on that load. These batteries, capacity can vary from data center to data center. Focusing on the affected data center here, these were sized to support 5 minutes of full load at the end of their life. During this event, the UPS batteries, we observed them supplying power for approximately 12 minutes. The second component that's worth mentioning is the static transfer switches. These are switches in our topography that can provide nearly instantaneous, uninterruptible power to critical loads by automatically shifting to a backup source if they sense a primary one being unstable or entirely has failed over. So under normal circumstances, Sammy, these four major electrical components work together to automatically instantaneously respond to power interruptions or other electrical system anomalies, depending on where it happens in the topography, to maintain that steady power supply for our critical customer loads.
Well, that's great to understand, Dana. So that's how things ordinarily should work, and those are some of the characters in our story. But before we get to the trigger event of this incident, I want to understand what I think of as the trigger condition, which is we were in a bit of a strange configuration. What was atypical about, the power lineup before we had the fault that caused it? There was some kind of repair or maintenance going on?
Yeah, thanks, David. And going back to what Sammy had mentioned at the very beginning about, hey, power interruptions and anomalies do happen, right? They're not that uncommon. I think I'd make 2 points before I jump into that trigger condition discussion. The first is that in my experience, in what we've seen, is that events like this are rarely attributable to one single thing. In these sorts of events, it's typically an overlapping set of unique circumstances, decisions, equipment issues that just happen to line up in the right place or the wrong place in order to lead to an event like this. And in this case is really no different. The second point I would highlight is that this is still an investigation that's in progress. We've learned things since we issued our post-incident report a few days ago, and we're going to continue to learn things as much as we can as we move this investigation into a full closure. So circling back, David, to your question about the initial trigger condition, the event itself, as you mentioned, was on the 13th of August, but on Sunday, the 10th of August, while we were conducting routine operations at the data center, one of the site's utility feed transformers experienced a low voltage condition on one of its output phases. This led to the vacuum fault interrupter in that transformer to open, and that causes a loss of utility feed, and the site successfully and automatically transitioned over to generator power. Troubleshooting of that potentially failed transformer required a specialized vendor that was not immediately available on the site. And so the local team shifted into an atypical system lineup that provided redundant utility and generator power, and it provided UPSs. But it did two crucial things. The first is it routed those potential two power paths through one common electrical busway, and it limited the ability of our static transfer switches to automatically make that near instantaneous switch over to a new stable source if needed, that I talked about just a few moments ago. Without overloading this discussion into too much detail, it is worth noting that there were several different lineups that were available to the operators in that stage. We build these data centers with a variety of redundancy and paths in order to give flexibility and be able to respond to a variety of conditions. And each would have its own pros and cons. And we are going to focus more attention there as we close out our causal analysis to make sure that going forward, we make sure we choose the most redundant and the most reliable lineup that we possibly can. But at a high level, that brings us back to your question about the trigger condition. This is the condition that the data center sat in for 3 days while we went to work to get that transformer anomaly troubleshot and repaired.
So I do want to tip my hat to. I think it's really important to stress that we seldom have a root cause, and complex systems fail in complex ways. And as you said, going back to before the event started, things went in action that would have been contributing factors to this. When this event happened, and I know a blip, a switch, they can be seconds, microseconds, nanoseconds even. How did we detect this? How did we investigate this? What were the steps that we took to mitigate this as this unfolded?
And as you're talking us through that, Dana, if you could help understand the trigger event as well, the ground fault itself, and then what we did after that to detect it.
Yeah, perfect. Will do, David. Thanks. So at approximately 2:20 UTC on the 13th, I mentioned earlier that we had the electrical power was routed through one common electrical path into our IT loads in this portion of the data center. A short circuit happened in that mechanical busway connection. It was a failed component. We've just recently completed disassembling that component and shipping it off for some forensic analysis. So the full details of what caused that component to fail are not yet known, but we'll get to the bottom of it. When that event happened, the utility circuit breaker opened and we had a loss of utility power. As discussed earlier, by design, the power distribution system should be able to transition over to emergency generator with the uninterruptible power supply batteries picking up load and the diesel generator coming online. Unfortunately, in this lineup, with the static transfer switches configured in the manner that they were, the generator output breaker was also aligned to that bus that had the short circuit and ground failure on it. Therefore, the generator could not pick up load. In this situation, the UPS batteries lasted for approximately 12 minutes, as I mentioned, and after which there was no power to supply the IT loads, and we lost infrastructure power at approximately 02:30 UTC, affecting our customers. Before I hand it back to you, David, Sammy had asked a question about how did we know this was happening? When that initial circuit breaker on the utility opened at approximately 02:20, we immediately received an alarm condition from the electric plant monitoring system. And so the team in the data center was aware of and immediately responding to that condition.
Got it. That's helpful to understand. So, okay, we've got that initial ground fault that ordinarily, wouldn't have caused a problem, but because of that weird configuration that flowed forward. So we detected it pretty quickly. It sounds like the team on site was aware of it. What happened next? How did we go about investigating what happened, and ultimately, how did we kind of mitigate the issue on site?
Yeah, in any of these power-related events, there's a personal and equipment safety aspect that comes into play very quickly. We're talking about voltages that can be hazardous to life. We're talking about large currents. And so the team immediately has to start thinking about what is the condition of the facility? Is it safe to our staff and the infrastructure in the condition that it's in? And what do we need to do in order to get power back as rapidly as possible? And so they began walking down, if you were in the data center watching this team as this unfolded, they begin to walk around the facility looking for abnormalities, and they look at the electric plant monitoring system to see the indications that they have, to see if they can deduce where the issue was. As that was progressing, the team was troubleshooting and trying to isolate that fault. They came to the decision that they would need to re-enable that static transfer switch ability to go back to a different power supply. I'd mentioned earlier that functionality had intentionally been disabled on the 10th of August. When that happened, in this case, there was a fully charged UPS battery set on that bus with no other source of power. So as soon as the local team restored that static transfer switch ability to seek out a good power source, it shifted over to the UPS batteries on that unaffected busway and reintroduced power to the critical loads. And that happened at approximately 0404 UTC. This began a process by which some of our critical loads and infrastructure began that automatic rebooting process. The UPS batteries will only last approximately 12 minutes, and so power was secured again at 0416. Final power was restored at 0508 UTC when the team locally completed bringing utility power back to that other side of the static transfer switch and restoring full power.
And so to understand, I know as we spoke in the PIR about a second power interruption. And is that second power interruption, right? We switched over to the UPSs, we were with them for a while, but then there was a second blip. We didn't talk too much about it in the PIR, but as you said, we're learning more as this incident progresses now.
That's exactly right. In this event, the two different set of UPS batteries, each individually carried loads for 12 minutes. At the very beginning of this event, from 0220 UTC to approximately 0232, those were carried by the on-service UPS, I'll call them set A. Later on in the event, as the team was attempting to configure the topography into a stable condition to restore utility, a second set of UPS batteries that were fresh came online and restored power for approximately 12 minutes. Does that answer your question, Sammy?
Absolutely, yeah. Thank you very much.
Yeah, I think that's interesting to understand, because in reading through the timeline in the post-incident review, it kind of makes it look like there was a power fault and then we fixed it and then there was a different power fault. But based on what you're saying, Dana, it sounds more like that we restored power too early before the whole lineup was ready to handle that. Is that closer to what happened?
Yeah, it's a great point, David. One of the ongoing discussions that is going to take us some time to work through is how do we balance speed of power restoration versus restoring power that will be stable and not experience further anomalies. This is pretty rare. This sequence of events is pretty unusual. And we have more to learn from that sequence and what's the optimal way to position the infrastructure to support our customers and our services.
Yeah, that's well said, and I love that we've already learned a lot from this, and we're continuing to do some learning. Now, this is probably a good time for us to bring Francis into this. So Francis is one of our engineering managers from the compute team. And Francis, I understand that this, breathing life back into or restoring power back into some of our compute infrastructure and then taking it away later, that kind of interrupted some of the restoration process. So could you talk us through, from a compute perspective, how should compute handle power being restored, and what actually happened during this incident?
But typically during power-related events such as this, the machines that are in the data center all boot up right after power is restored. Everything is configured so that as soon as power comes back, the whole thing boots back up and all services are restored as quickly as the software allows for it. And that did happen for a lot of the servers that we were experiencing this issue in this incident. The challenge was that some servers were stuck in a state where the second interruption of power resulted in some of the software not really coming up to a state where they were restoring the VMs to a healthy state. And the challenges here were of two kinds. There was a couple of issues where the OS itself was stuck on its ability to boot up. And there's another issue where some of the software was encountering state files that were in an inconsistent state. And the reason for all of these things happening was because during the initial power restoration, these services were all starting up, and this interruption, the second interruption coming in, interrupted a lot of the workflows that the software was going through, that in setting up the environment for these virtual machines to boot up. And this, as Dana pointed out, is a rare enough event that it's something that we hadn't experienced before. And we saw a bunch of servers that ended up in a stuck state, which required a lot of humans to intervene and repair them manually in order to kind of deal with the long tail of VMs that weren't coming back up.
So, and I know the timeline for the incident is quite broad, and it's cool that 95% of servers managed to get back up, which means all those dependent services that we spoke about earlier kind of got up quickly, and it was only the 5% where this was a long tail. This 5%, Francis, was there anything unique about these servers? Was it a different BIOS? Did they have particular hardware? I'm curious to know why this 5% were the unfortunate few, and it's great for our customers that 95% recover quickly, but let's focus on those 5% for a little bit more if we can.
Yes, the 5% were the long tail that I was referring to. They did not really have anything different than the other servers out there. And this was purely a timing-related race condition, if you will, where the second power outage just hit them at the very inopportune moment when the software was writing out critical files that were essential to be in a consistent state when the server boots up. And those files were left in an inconsistent state when the power interrupted right in the midst of it. So it was a very timing-related issue. So it just happened to get turned off right at the most inopportune moment. And that kind of resulted in what we ended up seeing in this long tail with the 5%.
Got it. That's really helpful to understand. So we can blame the data center team for that part of the false power restoration there. So this brings us full circle to some of our learnings and repair items. Dana, maybe we'll come back to you. We'll start with the data center team. But what are we going to do differently moving forward? And I know some of the investigations are still ongoing, but we already have some learnings or some repair items that you and your wider team are implementing. Can you talk us through some of those?
Yeah, absolutely, David. I think it's important before we get into the specifics just to reinforce the approach that we take in these learnings and how we apply them going forward. You know, we fully acknowledge that we exist to support the customers and the businesses that use our services, and we understand that it had an impact on those services. And so we take this responsibility very seriously to make sure that we learn everything that we possibly can from these sorts of events and put measures in place to improve our resiliency and our performance going forward. To that end, we've taken some actions to resolve the utility transfer that I mentioned that had happened on August 10th, and we've removed that damaged busway and is sent off for analysis. We're also working on our response protocols to de-risk those scenarios and to reduce the time from the 10th to the 13th, where we were in a little bit of a reduced state of redundancy. And we're taking actions to make sure that we have crisp processes and procedures to identify and communicate those associated risks clearly through our stakeholders in the business to make sure that we are aligned and everybody understands the operating conditions of the data center. The last thing, and we've talked about it briefly, is we're making sure that we're working with our internal partners to look at the way in which we restore power during these unusual events. Are there things that we really should avoid in that sequence? Or is this such a unique situation that in the 99% other cases where we just get the power back as rapidly as possible, that's the best approach to take? And these types of situations are extremely rare. More to come on that, David. You know, we have to look at that a little bit more deeply. Does that answer your question?
Yeah, that's great to hear that the data center has some learnings as well.
Super. And Francis, if I can pivot back to you again, but before I actually position the question, I think it's great that our customers who configured Zonely and even customers who weren't, for the 95% would have experienced quite a rapid recovery. When I think about the repair items, my default is to say, do you have a repair item for, you know, a double disruption of power during boot sequencing? I mean, it seems like such an edge case in a rare scenario for happen, but I'm so curious to know what your learnings and your repairs are for that.
Yeah, definitely. We typically do respond very aggressively to learnings from such incidents, and we did definitely book repair items to handle these edge case scenarios. And we will also, in addition to kind of building in that resiliency to the software, to make these file accesses a little bit more transactional, and survive such interruptions going forward. In addition to that, we will definitely also explore bringing in additional drill-based testing, right? So as you're aware, we do power outage drills relatively frequently in Azure. We tried pulling the power on some of our canary regions relatively frequently and exploring what breaks. These quick succession power outages scenario is not something that we've tried in the past. We will definitely explore that as an option as well and find out what else is potentially going to go wrong. In this outage, what we did was we did go deep. We figured out all the various scenarios which resulted in that long tail of failure. Like I said earlier, we discovered a couple of different failure modes, and we will definitely be working on the repairs to make those failure modes disappear in the hopefully the next outage, which hopefully doesn't happen. So, but we are definitely working on the repairs on making these components on the software side more resilient as well.
Yeah, that's a great summary, Francis, and a really helpful lens on, customers will ask us, what was the root cause? And I think as you've talked about and as Dane has talked about, there's so many contributing factors here that we can learn from. And so our job really is not to try to find the one smoking gun. Our job is to find and learn from as many of these different factors and events and conditions as possible. So that's a great summary. So we've got learnings from Datacenter, we've got some learnings from the compute side. And I've saved my last question here for my co-host, Sammy, since Sammy runs the Azure communications team. I'd love to know, how did we do from a comms perspective? Did we keep customers up to date during these power issues?
Interesting. So the first communication came out within 50 minutes of the interruption. This communication came out by Brain. Brain is our automated system that notifies impacted customers, typically within 15 minutes, and we notified quickly. It was for virtual machines. 5 minutes after that, we had PostgreSQL communicated to again, and then VMS, virtual machine scale sets, were communicated to after this. The Brain system worked pretty well, and it kind of communicated to a lot of the customers where the service had been onboarded to Brain. Not all services are onboarded to Brain, and there's reasons for that. We have to make trade-offs around how frequently do those outages happen, and how big are the blast radius, how critical are these, and so scenarios like virtual machines take a high priority. Some of the PaaS services that might be tier 2 with a less of a blast radius may not be onboarded to Brain immediately. One of the things I think that we're reflecting on is around 2 hours into the outage, we recommended to customers that they should consider invoking their BCDR strategy. And I don't think it's a great time to do this. And I don't think that Microsoft is in a position to tell customers to invoke a BCDR strategy when one part of one zone is down. Customers who had configured for zones were pretty much unaffected. BCDR is resilience in the beginning is worth pulling the lever on BCDR. It's a very expensive thing. And so when Microsoft recommends it or recommends contemplating it, I think it sends mixed messages to customers. Our job is to tell customers what's going on, and they can make their own decisions. If we think that we're losing a region, of course, we'll tell customers what's happening there so they can make that decision. Overall, our comms were automated for the most part. We didn't start talking about what happened until we were pretty much almost recovered. Part of this is to do with tooling and complexity. As Brain fires its alerts, it creates a different tracking ID in a different kind of area. And so updating different groups of customers simultaneously with the update becomes tricky. So we do have tooling repair items. But overall, I would say customers were informed quite quickly about what was going on, and they had information, but we didn't pepper in the detail where we are with recovery, what we understood the causes to be. And while this may not have changed the outcome, it's really important that as the communications team, we're bringing customers along the way for the journey. We're letting them know how close we are, what's working, what's not working, and what we're assessing. We really think that strong communication can build strong trust, strong empathy. And I think while we automatically communicated quickly, we could have done more with better storytelling.
Got it. That's helpful. So maybe it was quick and those automated alerts were helpful to get the initial, hey, it's Azure, it's not you, but we could have peppered in more detail. I like that use so that we can be even more transparent about what's happened. Okay, so we've got learnings all around. Thank you for watching this Azure incident retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.